Hello everyone, Navid here at HVACroom.com. In this video, I'm going to talk about medium pressure system. So this is the example that we had for the previous session. We talked about low pressure system like a constant volume rooftop unit. Today we are going to change this system to a medium pressure system. If you guys ready, let's get started. So for a medium pressure system that we usually use for the commercial projects and maybe industrial projects, instead of this system that all the branches goes to each diffuser, we're going to have VAV boxes, or we are going to have supply air valves. So the system is going to be like this. We have the same structure, but again, instead of diffuser for each branch, we are going to have these VAV boxes. For these VAV boxes, we can get the system with hot water reheat coil, which is going to do the reheat for us. Again, for this reheat, if the project is small, we can go with electric reheat also. But the question is, how do we size the system now? We change the system from low pressure to medium pressure, but how we are going to size the system and what type of criteria do we have here? So as far as the criteria, this is what we usually use for a medium pressure system. Basically, if I want to talk about the pressure drop and also the velocity on this structure, so let's say we have a rooftop unit or air handling unit here, and on each branch we are going to have these VAV boxes, right? After each VAV box, again, we are going to have the same structure with diffuser. So for this part, we call it low pressure system, but from air handling unit to each VAV box, we call this section medium pressure. So again, when you are changing the system from low pressure to medium pressure, you're going to have two combined system, low pressure and medium pressure. For the low pressure system, we talked about it last session, and you guys know how to design and size this ductwork here. But from this spot that we have the air handling unit to each VAV box, we're going to go with this criteria. The friction rate is going to be about 0.25 inch of water gauge per 100 feet. And the velocity is going to be in this range, 2200 to 2500 foot per minute. For example, again, we're going to have the same system that we had before. I changed the CFMs a little bit. Actually, they are bigger now. So I want to look at the chart and determine the size of this duct. We have 4000 CFM, and we're going to go with the same criteria that I just explained for medium pressure system. So here I go back to the chart. From 0.25 inch of water gauge, I select that in the chart, which is going to be here. Remember, for the low pressure system, we had this line, if you remember from the last session. So this is going to be your friction rate, and we do have 4000 CFM. And if you look at the intersection point here, we are between 18 and 20. And if you look at the velocity, it's about 2000 foot per minute, which is perfect. So this duct is going to be 20 inches diameter round. So here we're going to have 20 inches. Again, you can repeat the same criteria for all the other sections. Let's say we're going to talk about this section. We have 3100 CFM. I go back to this chart. 3100 CFM is going to be around here. So again, the size is going to be between 16 and 18. And the velocity is about 1900, which is awesome. So as far as the size, I can call it 18. So here we are going to have 20 inches, we are going to have 18 inches. And for these two sections, you can do this as an example and put your answers in the comment below. Please like and share with your friends if it was helpful.